In our Chapter 6 review, question number 4, Colin is on a unique Ferris wheel. It is situated on the top of a building. Colin's height above the ground at various times is in the table. So what I did first was I graphed the function. So this is the data plotted for Colin's Ferris wheel. Part A asks for what is the period. The period is the length of time between one complete cycle. So here we are at the top of the Ferris wheel. It goes down and around, and then we're at the top again over here. So then this is the period. The length of that period is from 0 to 80, so 80 seconds. So next we'll look at the axis. The equation of the axis. So the axis goes through exactly the middle of the curve. We look at our maximum is at 25 and our minimum is at 7. The axis will be halfway between that. Halfway between 7 and 25 is 16. So our equation of the axis then would be y equals 16. Our amplitude is the distance from the axis to the maximum or from the axis to the minimum. That's our amplitude. And in this case, our amplitude, or A, equals 9. In terms of Colin's Ferris wheel, the period represents the time it takes to do one complete revolution in the seat. The equation of the axis is the midway point between the top of the Ferris wheel and the bottom of the Ferris wheel. And the amplitude would represent the radius of the Ferris wheel. Part D asks if the Ferris wheel was already in motion when the experiment began. So we look at time 0 right here, and we go up, and you can see it's at the maximum. So obviously the machine must have already been in motion because it's at the top, and we don't generally board a Ferris wheel at the very top. So yes, it was in motion when time got started. To determine how fast the Ferris wheel is going, we need to know how big the Ferris wheel is around. So one revolution happened in 80 seconds. We learned that. So that will be the seconds that we use. But to find one revolution, we're going to use the circumference formula. The circumference for this Ferris wheel will be 2 times pi times r, and the radius is the same as the amplitude, so we're going to use 9. So the circumference of the circle then would be 56.55 meters. One revolution is 56.55 meters. And we know from our period that happens in 80 seconds. So one revolution, 56.55 meters in 80 seconds. So once I punch that into the calculator, it's 0.71 meters per second. That is how fast the Ferris wheel is going. Okay, the two final things to do is to determine the range. The range is the set of y values that go from the minimum to the maximum, so from 7 to 25. So the range then would be 7 is less than or equal to y is less than or equal to 25. Now, part G asks, if the building is 6 meters tall, what was Colin's boarding height in terms of the building? We can see that he's probably going to be boarding at the lowest point, of course, so that's 7. And so he boards at 7 meters. That's including the building. So 7 meters is the boarding height minus the building at 6 meters. He is 1 meter above the building in order to board the Ferris wheel.